Hi, I'm Patty with Amplify Science. I'm going to lead you through this unit orientation video for the 5th grade unit, the Earth System. In the Earth System, students take on the role of water resource engineers, where they learn about the Earth System so that they can help figure out what's causing the water shortage on one part of an island. They also design ways to alleviate the effects of water shortages, including freshwater collection systems and proposals for using chemical reactions to treat wastewater. Students are introduced to the cities of East Ferris and West Ferris, which are located on different sides of a mountain on the fictional Ferris Island. East Ferris is having a water shortage, while West Ferris is not. Investigating what determines how much water is available for human use leads students to explore how parts of the Earth system interact. As they work through the 5 chapters, they gather evidence from multiple sources by doing, talking, reading, writing, and visualizing. Their explanations become more complex over time as they figure out how water is distributed within the hydrosphere and how water moves between the hydrosphere and the atmosphere to cause rain. They'll learn how the geosphere can interact with the hydrosphere and atmosphere to create patterns of rain, and how life forms in the biosphere depend on the hydrosphere. This unit is an engineering design unit. In their role of water resource engineers, students particularly focus on developing skills with the science and engineering practices, developing and using models, planning and carrying out investigations, and constructing explanations and designing solutions. Students learn about scientific explanations and have multiple opportunities to write increasingly complex explanations of the water shortage on a fictional island over the course of the unit, synthesizing ideas from a variety of sources. Students are also challenged to design solutions to the water shortage. They design, build, test, and iterate on systems that can collect fresh water from salt water. The focal cross-cutting concept in this unit is systems and system models. In their role as water resource engineers, students delve deeply into the Earth system and its interacting parts as they investigate water shortages, rain formation, and evaporation. Through these investigations, students construct an understanding of how the hydrosphere, atmosphere, and geosphere interact to affect rainfall patterns and how the biosphere affects water availability. Students apply their systems lens to engineering design as they construct systems for collecting fresh water from salt water. They return to the idea of systems again and again throughout the unit through a variety of modalities. Every Amplify Science elementary unit also includes a focal sense-making strategy, which students leverage as they read and also during investigations. This unit's sense-making strategy is synthesizing. Like most units in Amplify Science K-5, the main writing genre is explanation. Well, that's it for the overview. Now I'll talk you through what happens throughout the unit, how students build from their prior knowledge to get to a complex causal explanation of the anchor phenomenon. To do this, I'll summarize the key ideas students figure out in each chapter and how they use these ideas to explain the anchor phenomenon piece by piece. For each chapter, I'll highlight a few key evidence sources students use. But remember, in every chapter and indeed every lesson, students gather evidence multimodally from many different sources. In Chapter 1, students work to find out, why is East Ferris running out of water while West Ferris is not? Students investigate and learn almost all of Earth's water is salt water in the ocean. The limited amount of fresh water is mostly in glaciers and groundwater. The amount of available fresh water decreases when people use more than the amount that flows into their area. Key evidence sources here include information gained from analyzing graphs of global water distribution, reading the book Water Shortages, Water Solutions, and using media to see video of water flowing in and out of a reservoir at different rates. At the end of Chapter 1, students return and apply these ideas to the anchor phenomenon. They explain that Ferris Island is surrounded by ocean, but salt water is unusable for most human purposes. East Ferris's growing population is using up their only fresh water source, a groundwater reservoir, whereas West Ferris has an additional source of fresh water, rain. In Chapters 2, your students will try to figure out why more rain forms over West Ferris than East Ferris. Students figure out that rain can happen when water vapor gets cold and condenses into liquid water. When water molecules are spread apart, they're water vapor. When enough water vapor gets cold, the water molecules move close together and form liquid water. This is condensation. When enough liquid water condenses from water vapor, rain can happen. In this chapter, students investigate and observe how drops of water form and then use the SIM and modeling tool to create digital nanoscale models of how raindrops form and where water vapor comes from. At the end of Chapter 2, students are able to explain that more rain forms over West Ferris because more water vapor condenses there. During condensation, water vapor gets colder and turns into liquid water. There's a lot of water getting cold in West Ferris, so a lot of rain forms. There's not a lot of rain forming over East Ferris, so there's not a lot of water vapor getting colder and condensing into liquid water there. In Chapter 3, your class will work to figure out why is more water vapor getting cold over West Ferris than East Ferris. Students investigate and find out that water vapor condenses as it moves higher to where the atmosphere is colder. Water molecules move close together and form liquid water high up in the atmosphere because that's where it's cold. This is what causes water to condense from vapor to liquid. In Chapter 3, key experiences include students visualizing condensation using the SIM to gather data about where and at what temperature liquid water forms in the atmosphere, and then using the data tool to make and analyze graphs of data collected in the SIM. By the end of Chapter 3, students are able to explain that there's more water vapor getting cold over West Ferris because on that side of the island, more water vapor moves upward in the atmosphere where it's colder. This means that more water vapor can condense and fall as rain. In Chapter 4, students investigate the question, why is there more water vapor high up over West Ferris than East Ferris? They discover that mountains can redirect water vapor higher in the atmosphere. Wind can move water vapor to other places in the atmosphere. When the wind is blowing toward a mountain, the mountain can change the direction of the wind to direct the air upward. This causes the water vapor, which is part of the air, to move upward to where the atmosphere is colder. In Chapter 4, students use data from digital and physical models to engage in a roundtable discussion about rain formation and the rain shadow effect. At the end of Chapter 4, students explain that there's more water vapor getting cold over West Ferris because on that side of the island, more water vapor moves upward in the atmosphere where it's colder. This means that more water vapor can condense and fall as rain over East Ferris. In Chapter 5, students apply earlier understandings to help answer the question, how can East Ferris turn wastewater into clean fresh water? They use ideas about chemical reactions forming new substances and matter being conserved in chemical reactions as they work in the role of water resource engineers. They'll decide which substances to combine to control the results of chemical reactions as they design solutions to protect Earth's resources. In Chapter 5, students analyze images and diagrams of chemical reactions and manipulate substances in reactions to determine which combination of substances cause certain observable results. Then they write a scientific explanation to answer the Chapter 5 question and engage in a town hall meeting discourse routine to discuss the causes of the East Ferris water shortage and possible solutions. At the end of Chapter 5, students are able to explain that East Ferris can add substances to wastewater that react with the harmful substances in the water. The reaction creates new substances that are easier to remove from the water, so East Ferris can get clean, fresh water. I hope you're looking forward to teaching this unit and that you're feeling a little more prepared to dig in after watching this video. In addition to the resources on the Amplify platform, check out the at-home videos and at-home unit to help you teach the unit remotely. The Spanish at-home unit will be out January 28th. You can use any combination of these resources to engage your students in figuring out the Earth system. Please let me know how I can help you plan for instruction. I'm Patty Works, and my email address is pworks@amplify.com. Thank you very much for joining me today.